The world of mobile app development is complex and expansive. If you're starting a new project, you likely feel overwhelmed by all the options. So you decide to do some research to figure out what's the best tool for you. According to Google's AI overview, Flutter is best for high-performance apps, whereas React Native is best for near-native performance. Kotlin Multiplatform and SwiftUI, despite actually being native frameworks, include no mention of performance at all. And if you want to know which framework is the best, it's all of them. If you're skeptical about these claims, you can do some deep research using real human opinions from real human developers on Reddit. Is Flutter slowly dying? Is React Native really that bad? Jetpack Compose is a great idea, but poor implementation. Why is native script so dead? Is SwiftUI really the future? Hell, even I've contributed to the pool of collective knowledge. If you watched my video about React Native, you may have noticed that I was very careful not to endorse any particular mobile app framework. That's because I legitimately don't know which one is the best. But today I'm going to fix that. In this video, I'm going to build the same app with 6 different frameworks and give my opinion on what framework you should be using for your projects. The app I'm going to be building is a simplified version of the Reddit app. It'll only display the top posts for each subreddit in the past 24 hours. This way, I won't be tempted to waste time scrolling endlessly looking for more news. If you didn't know, you can add .json to the end of a Reddit URL to get the posts in JSON form. I assume there's some rate limit when doing this, but since I'm fetching about 50 posts total, I'm going to fall well below the rate limiting threshold. I kept it extremely simple because I am going to build this 6 separate times. I'm going to evaluate each framework based on installation complexity, debugging experience, state management, and any roadblocks that come up during the development process. So let's get started. SwiftUI was created in 2019 by Apple to replace their existing UIKit framework. So you could say SwiftUI is the new native framework for iPhones. It took me about 1 hour and 50 minutes to build my app, which isn't very fast, but keep in mind that this is the first framework I used. The binary size is 1.8 megabytes, and the startup time is 0.683 seconds. I would take these startup time measurements with a grain of salt, since I'm only using a sample size of 1 app launch. Here are the good parts about SwiftUI. SwiftUI is native code for iPhone, so that avoids all of the problems that come with foreign function interfaces and interfacing between something like Dart or JavaScript and the actual native code. The SwiftUI preview system is pretty sophisticated. So you can see here this preview macro that allows you to specify what you want shown in the preview on the side. For demo purposes, I'm showing the preview in the iPhone simulator, but you can also have it work live on your actual phone. And this preview isn't just a static preview. You can click on things and actually have them send requests and store state and that sort of thing. So if you want to teleport to some state in your app, you could set up the preview in such a way that you don't have to click through your user interface to get to the state that you want to test. Another cool thing are these canvas device settings, where you can set the color scheme to light or dark, or change from portrait to landscape mode, or make the text bigger or smaller, which is very important for accessibility. Because a lot of people with vision problems will make the text bigger on the operating system level. The way SwiftUI does state management is awesome, because you don't need any third-party package to actually make it work. And it's basically using a lot of compiler magic to give you all of the safety guarantees and to make everything clean and simple. It's kind of hard to explain if you haven't seen how it's done worse, but we're going to see that later. So you put this @observable property wrapper on your class, and this essentially marks all the fields on that class as being state. SwiftUI tracks which state on your observable that you actually use, so it'll only re-render the view when that specific field that you're using changes. So it's kind of idiot-proof. Like, you can't really mess it up. I'm sure someone in the comments will tell me how they messed it up, but it's easily the simplest state management I've seen in a front-end framework. A really cool thing about Swift as a programming language is the way it does exception handling. So you can see here that I have this compiler error saying, call can throw, but it is not marked with try and the error is not handled. So the compiler tells you which lines of code can actually throw exceptions. So in my code, I cache the exception and set the error message. But let's say you didn't want to do that. Maybe there's nothing you can do with the exception. So instead, you can put try question mark, which is kind of like try or null. And then you can see here, we get another compiler error. That's because now Reddit response is an optional type, right? It's a nullable type. It could be null. So this makes way more sense than if you look at something like TypeScript or Dart or C# or most other programming languages. Here are the bad parts about using SwiftUI. There's no way of taking your SwiftUI app and making it run on Android devices, so you're going to need to use a different framework for Android. You're also not going to be using Swift for your backend, if you have a backend for your app. The Xcode AI integration doesn't have access to your file system, so if you want something like Claude Code to search through all of your files, or run command line tools, and Xcode comes with certain command line tools that you can use to build and deploy your app, so you don't have access to those within Xcode itself. And I would say, in general, there's a lot of things about Xcode that are not the best. Like a really obvious one is in the AI integration, I can highlight the code in the response, but I can't highlight the code in the prompt. And so if I want to go back and reprompt it with a slightly different prompt, I have to type everything out again, which is really stupid. And there's things like that all over Xcode. It's not the best editor experience. And the only reason I'm not bashing it more is the fact that we do have AI integration, so you have the option of mostly talking into a text box rather than actually having to deal with Xcode. But overall, my feeling on SwiftUI, I give it a thumbs up. Jetpack Compose was created in 2021 by Google to replace their existing native code for Android. JetBrains, the company that develops Android Studio, decided to release their own version of Jetpack Compose called Compose Multiplatform that can also build apps for iPhone. For my app, I'm going to use Compose Multiplatform to see whether it's viable for building iPhone apps. It took me 2 hours to build my app, which was a little bit longer than it took me to build with SwiftUI. The binary size is 36.9 megabytes, and the startup time is 0.483 seconds. Here are the good things about Compose Multiplatform. Jetpack Compose is native code for Android, which has the same benefits that SwiftUI has for iPhone. However, Compose Multiplatform isn't native to iOS, so I'm not actually getting those benefits here. Compose Multiplatform has previews similar to SwiftUI. The features are somewhat different, but I would say that overall they're still very useful. The state management is built into the framework itself, so there's no need for a third-party solution. I wouldn't say it's super intuitive though. Like this remember of a derived state of that listens to a mutable state list of, which triggers a recomposition when one of its data class entries is replaced with a .copy of itself. Despite how much of a mouthful that is to say out loud, I do think it's a sensible way of doing state management. I also like that they have data classes built into the language, as well as this object keyword for creating singletons without defining entire classes. Here are the bad things about Compose Multiplatform. There are 6 non-get-ignored build-related files at the top level of my project, but my actual code is 7 levels deep into the folder structure. And I know this is petty, but the naming of this thing is awful. Kotlin is made by JetBrains, whereas Jetpack Compose is made by Google. Kotlin Multiplatform is not a UI framework. It's literally running Kotlin code on multiple platforms. And Compose Multiplatform is a generalization of Jetpack Compose that runs on iOS. Remember that Google AI overview I showed you at the beginning of the video? These terms are so conflated that even the AI gets them wrong. Finally, since Compose Multiplatform is relatively new, the ecosystem for packages is relatively small. You'll probably need to implement some Swift or Objective-C on your own to get things done. Overall, I think Compose Multiplatform is a good choice for building Android apps, but it definitely wouldn't be my first choice for building an iPhone app. I guess if you already know and use Kotlin elsewhere, you'll find it pleasant to work with. .NET MAUI, or the Multi-Platform App UI, was created in 2022 by Microsoft as a new coat of paint on top of Xamarin Forms, which in turn was created all the way back in 2014. From what I can tell, the original intention of Xamarin Forms was to help developers port their apps to Windows Phone. It took me only 1 hour and 20 minutes to build my app, which I found extremely surprising. The binary size is 47.6 megabytes, and the startup time is 0.667 seconds. Here are the good parts about .NET MAUI. Here are the bad parts about .NET MAUI. Upon successfully installing MAUI, VS Code gave me this pop-up telling me that MAUI was not found. When I tried to run my app, I got an error that told me I needed to downgrade Xcode, even though I'm pretty sure I get locked out of Xcode if I don't upgrade. The original file names I used for the subreddit icons were invalid because they contained uppercase letters. MAUI uses XML files to specify the UI. then binds the stuff from the XML files into C# code. This is horrible, because the XML and C# files can get out of sync very easily if you rename variables. Now, I'm sure there's some Microsoft employee somewhere about to jump out of his seat to tell me you can use pure C# without any XML in MAUI. To that employee, please update the .NET new MAUI command that you proudly display on your homepage, because that's where the XML came from. Also, please add a gitignore file to your starter project. At least state management is straightforward. Private void on property changed. Private void on property changed. Caller member name string name equals null. Property changed dot invoke this new property changed event args name. Overall, I have no real complaints about .NET MAUI because I don't have to use it. React Native was created in 2015 by Facebook to make cross-platform app development easier. From nearly the very beginning, another company called Expo developed a meta framework, also known as Expo, as a batteries-included way of developing React Native apps. It took me only 40 minutes to build my app, which is at least twice as fast as anything I've tried so far. The binary size is 32.1 megabytes, and the startup time is 0.483 seconds. Here are the good parts about React Native. If you're a web developer, you'll find it relatively easy to get started with React Native. TypeScript has a massive ecosystem of packages, many of which are unrelated to mobile development, but are nevertheless useful for things like sending network requests, interfacing with on-device SQL databases, and more. With React Native, the AI is noticeably more accurate when following instructions, which saves a ton of time not needing to tell the AI to fix its mistakes. Expo provides a way for you to deploy apps to your iPhone without using a MacBook. Basically, they created this app called Expo Go that loads your JavaScript into their app. It has some limitations related to native code, but it's extremely convenient if your app involves all JavaScript and no Swift or Kotlin. Here are the bad parts about React Native. The package.json file lists 25 third-party packages as part of the Hello World project. I'm pretty sure only 5 of these are actually used in the project, but I'm also pretty sure that if I remove any of them, then something will break in the future. I can't imagine trying to deal with a bug in one of these. Expo's page routing is a bit clunky. The page names are tied to the file system paths, and the TypeScript types aren't generated until build time. So if I rename a folder in VS Code, the error won't appear until my next build. I also can't press F12 in VS Code to navigate to the page, and the params aren't automatically type-safe. State management in React is very good and simple if you know what you're doing. But if you're a beginner, you'll almost certainly screw it up. Screwing it up, in this case, means that your app is going to drop a ton of frames anytime there's an animation, or when you type into a text field, the characters won't show up as quickly as you're typing them. And trust me, I've worked at a company with tens of thousands of lines of unnecessary prop drilling code. It's a major time sink to refactor your code with good state management. If you ever want to debug or write any significant amount of native code, you lose basically all of the benefits of using React Native or Expo. I think this is largely a result of the fact that Expo wants you to use their cloud services so they can make money. Like the starter project doesn't even have an Xcode project you can open for debugging, and you lose hot reloading if you do manage to build and install the app outside of Expo Go. Let's be honest, the average React Native developer doesn't own a MacBook and probably doesn't care, but the initial convenience of using React Native won't last forever. Overall, if you're building a web-ish app and you know you won't be writing any Kotlin or Swift code, I give React Native a thumbs up. Otherwise, it's kind of mid. Capacitor was created in 2018 as a way of packaging websites into mobile apps. It's the spiritual successor of a project called PhoneGap, which goes all the way back to 2008. It took me 1 hour to build my app, which is about middle of the road compared to all the other frameworks I tested. The binary size is 4.1 megabytes, and the startup time is 0.850 seconds. Here are the good things about Capacitor. Web development tools are much nicer than mobile development tools. Here are the bad things about Capacitor. If you have a web app that uses server-side rendering, like with Next.js, you can't just plop that into a mobile app that's supposed to work offline. Also, it turns out that web pages don't look and feel like mobile apps. To fix both the routing and look and feel problems, you can use a UI library called Ionic, which is made by the same people who make Capacitor. However, the routing is not type-safe at all. The styling won't mesh well with other web styling frameworks, like Tailwind, and the more that I polish and improve my app, the more it feels like it's turning into a React Native project. The way Capacitor renders your user interface is by basically spawning a little mini web browser inside your app called a web view. This is why the binary size of the app is nearly the same as a native SwiftUI app. It's also probably why the startup time is the slowest out of all the frameworks I tested. It has the startup time of native code, plus the startup time of the web browser. Overall, if I wanted to embed a web view into my mobile app, I could do that with literally any framework. There are no glaring issues with Capacitor as a framework, but I'm not sure why I would pick it over React Native. You might like it if you hate React. The final framework I'm going to be testing is Flutter. Flutter was created in 2017 by Google to make cross-platform app development easier. It uses its own custom programming language called Dart, which is largely inspired by both Java and JavaScript. One of Google's original strategic goals with Flutter was to make app development simpler for their unreleased Fuchsia operating system. But these days, I'm not sure Fuchsia is such a priority for Google. It took me about 50 minutes to build my app, which was slightly slower than with React Native, but still significantly faster than any of the other frameworks tested. The binary size is 15.8 megabytes, and the startup time is 0.500 seconds. Here are the good parts about Flutter. Hot reload with Flutter is totally seamless. You hit F5 in VS Code, and it runs the app on your phone. When you make changes in your code, it updates the app on your phone. Very simple. Similar to React Native, the AI is very good at writing code correctly on the first try. Generally speaking, Flutter has the least number of quirks compared to other frameworks. This is mostly because Flutter doesn't build on top of any prior framework, so Google can unilaterally change things without breaking other use cases. Like the React Native creators can't decide to change things about JavaScript if they don't like them. Here are the bad parts about Flutter. I haven't mentioned it so far, but I've been debugging the apps on my phone wirelessly. While Flutter can debug apps wirelessly, it takes like 90 seconds for the debug session to launch. So I ended up plugging my phone into my computer to make it go faster. Flutter has very similar state management to React Native, and like I mentioned with React Native, it's very easy to completely destroy the performance of your app if you're not careful. Most importantly, there's no ecosystem for using the Dart language for your backend, which means you'll need to use yet another programming language in your project. Overall, Flutter is a jack-of-all-trades, master-of-none kind of framework. It's not really the best at anything, but it avoids most headache-inducing situations. So which mobile app framework should you be using? Let's do a tier list. If it wasn't clear going into this, most of my experience has been with Flutter and React Native, so those are my biases. I expected SwiftUI to be in C tier, because Xcode is such a scuffed editor, but SwiftUI's state management really blew me away, so it goes in A tier. Compose Multiplatform was hyped up so hard online, so I thought it would be an A tier, but it doesn't seem much better than Flutter for practical purposes. There's fear that Flutter is losing momentum, especially given Google's track record of killed by Google, and that Compose Multiplatform will become the future. But I seriously doubt Google would outright kill Flutter. They would probably just leave it in maintenance mode. And compared to Compose Multiplatform, Flutter has been around longer and already has a large ecosystem of developers. I think they're both B tier. .NET MAUI goes in D tier. No matter how ridiculous and outdated I think it is, I was able to successfully build my app with it. There's nothing that really stands out to me about Capacitor. It seems like the kind of thing that no-code companies would brag about, but I don't actively hate it, so C tier. Finally, React Native. I saw this Reddit post a while ago that showed SpongeBob bowing down and worshipping Expo like it's some kind of god. I didn't know SpongeBob was a web developer, but I'd have to say that React Native goes in B tier for most use cases. There isn't a one-size-fits-all solution for mobile app development, but at least you know a little bit about all the options out there. If you enjoyed that video, make sure you smash that subscribe button. Shout out to all my Patreon supporters, and I'll see you guys next week.